Hello Internet, Parag Dhawan here. We are on day 5 of 30 days ML challenge by Kaggle. In part 3 of this video, we will read tutorial on loops and list comprehension. Click on the link, loops and list comprehension. Click on edit my copy. This will start the Kaggle workbook wherein you can do your changes after execution of chain cell. Loops. Loops are a way to repeatedly execute some code. So, in the first example, we are creating a list which is a list containing various planets. For iterating over a list, we are using for loop. For this planet is a variable which will store the elements of planet list. So for planet in planets, so planet will access one by one: Mercury, Venus, Earth, Mars, Jupyter, Saturn, Uranus, Neptune. Inside the block of for loop, we are printing planet, and we are ending our print statement instead of a backslash of n by a space. So in the first iteration it will print Mercury, in the second iteration it will print Venus, in the third iteration it will print Earth, so until the last iteration it will print Neptune. Click on the cell and run the cell. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune was the output. The for loop specifies the variable name to use. Here we have variable use planet. The set of values to loop over, in this case planets list. You use word in to link them together. In operator. The object to the right of it can be any object that supports iteration. Basically, it can be thought of as a group of things. You can probably loop over it. In addition to list, we can iterate over a tuple. So in the next example, we are iterating over a tuple. So we have created a tuple using opening and closing parentheses containing integer element 2, 2, 2, 3, 3, 5. It is stored in a variable multiplication. We have used a second variable product, which value is 1. For every element here, this is index variable. In the tuple multiplicants, what we will do, we will update the value of product. Previous product into mult variable will update the product value. So when you run this for loop, for the first iteration, 1 into 2 will be performed, result will be 2. For the second iteration, 2 into 2 will be performed, result will be 4. For the third iteration, 4 into 2 will be performed, result will be 8. For the fourth iteration, 8 into 3 will be performed, which will be 24. So until the end of the tuple, updated value of multiplication is stored in product. Out of the for loop, we are displaying the value of product variable. Click on the cell and run the cell. You can see value is 360. You can even loop through each character in a string. So in the next example, we have a string S. There's a single line string enclosed in single quotes. So it is a string containing multiple characters. Message is also a string which is empty. What we have to do, we have to print all the uppercase letter in string S one at a time. So we are looping over the string S. So for char, every character, this is variable in string. So this variable will first time be S, for second time it will be T, for third time it will be E, means it will iterate over the string till the end of the string. What we have to check, whether the character assessed is a uppercase or not. So everything in Python is an object. String is also object, so string single character is also object. That object has isUpper method to check whether the character is uppercase or not. So after assessing the character inside the for block, we are running if statement. If char is upper, this condition will be satisfied or it will be failed. If it is satisfied, we are printing character on the user screen. If it is failing, then we will come out of the if block doing nothing. We will iterate to the next character, again check whether it is uppercase. If it is uppercase, we will print it on the user screen. Otherwise, we will skip the execution of this if block. Click on the cell and run the cell. All the uppercase character of the given string S was printed on the user screen. Now, moving to the next part, range function. So, we will see how range function is used inside loops. So, range is a function that returns a sequence of number. And it turns out to be useful for writing loops. So, here we are running a for loop. It will have a variable I and it will run in the elements generated by this range function. So if we press shift tab here, it will display the docstring of range function. You can see signature, range function, ranges of object. Inside the signature, it should be having a start value, a stop value, and an optional step size. If the start value is not specified, it is considered to be 0. Stop value, where it will run till stop value -1. So the second index will be generating number till second index -1. And step size. So from the start value to generate a next element, we use step size. By default, step size is also 1. Return an object that produces sequence of integer from start inclusive means start will be used to stop exclusive is last index -1 element will be fetched. For example, range of ij will produce a value I plus 1, I plus 2 till j -1. Start by default to 0. Stop is omitted. Range 4 produces 0 to 3. They are exactly the valid indices for a list of 4 elements. Okay. Now, when you are running range function, then you are starting from 0, you are running till 5 -1 and you are generating integers 0, 1, 2, 3, 4. Means you are running this loop for 5 number of times. And what you are printing the element of the range function which is generated. So inside the for block, what we are doing important work I, which will be printed as a comment on the user screen as it is. For the first iteration, 0 will be printed. For the next iteration, 1 will be printed. This will be repeated till 5 -1 means till 4. If you are starting the loop from 0 and running it till 4, you are running the loop 5 number of times. While loops. Similar to for loop, we have while loop which are used for iterating over iterable or executing a given statement and number of times. So loops have condition. So when you are using while loop, you have initialization, condition check, incrementation and decrementation. Here what we are doing, we are initializing a variable I by 0, applying while loop in the next statement. We are checking whether the variable I is less than 10 or not. This is iteration condition. 0 less than 10 condition is true. We will print the value of I 0 on the user screen, and we are updating keyword argument end of print statement. Instead of / of n, it is space. And then I is incremented by 1 using shorthand notation. I plus is equal to 1. So I 0 0 less than 10, 0 printed on the user screen, I value incremented, it becomes 1. Then check second iteration, 1 less than 10 condition is true, 1 will be printed and I is incremented to 2 less than 10 condition is 2, 2 will be printed, I will be incremented, I is 3, 3 less than 10 condition 2, 3 is printed, I is incremented to 4. This will be repeated till 9. When I value becomes 10, 10 less than 10 condition false, we will come out of the loop. Click on the cell and run the cell. You can see 0 to 9 printed on the user screen. The argument of while loop is evaluated as a Boolean statement, and the while loop is executed until the statement evaluates to false. In this case, our statement evaluates to false when I value becomes 10. List comprehension, important topic. List comprehension of one of the Python most beloved and unique feature. The easiest way to understand them is probably to just look for few examples. Here, we are generating a list using list comprehension. For we are looping over a range of n. So by this for n in range 10, we will iterate from 0 to 9, and for every element which is iterated, we are generating a new element which will be stored in the list. That is n to the power 2. So for every n in range 10, we are computing its square and storing it in the new list. The newly generated will be stored in the variable squares. So this list is generated will be square of 0 to 9 stored in squares variable. Click on the cell and run the cell. You can see for first iteration 0 was produced, 0 square is 0. For second iteration 1 was produced, 1 square is 1. For next iteration 2 was produced, 2 square is 4. So on. For last iteration 9 was produced, 9 square is 81. If this same thing was to be done without using list comprehension, you have to create an empty list square. You have to iterate over n in a range 10. So this loop will run from 0 to 9. To the square list, we will append element square. So if n is 0, 0 square is appended. If n is 1, 1 square is appended. If n is 9, 9 square is appended. And after this, we are printing square on the user screen. So if without done using list comprehension, you require 3 lines of code. If it is done using list comprehension, you require a single line of code. Click on the cell and run the cell. You can see the output of previous cell and the current cell is same. Now you can add if condition to list comprehension to filter out elements. So in the next example, we will see how we can use list comprehension using if condition. We have a planet list. So for an index variable in planet, it will assess every planet from the planet list. Then we will check if length of planet is less than 6. So we are checking whether the element accessed from the planet index is less than 6 or not. If it is less than 6, then that variable is used for generation of new list, and then that new list is stored in short planet. So this will give all the planets from the planet list whose length is less than 6. Number of characters are less than 6. So what was the condition applied? We selected a planet from the planet list, check whether the length of the planet list is less than 6. If those condition while iteration is satisfied, then only the planet was used for creation of the new list. Click on the cell and run the cell. We have seen there are 3 planets whose length is less than 6. If we are familiar with SQL, you might think as it being a where clause. So now we are seeing another example of filtering with if condition and applying some transformation. So you generate a result from list comprehension. That result is then updated and then stored in the resultant list. So here we are using list comprehension. So we are for planet. In planet means we are assessing every element of planets in planet list. We are checking whether the length of that planet is less than 6 or not. If this condition is satisfied, then the planet will be returned. To that planet, which is a string, we are applying upper function. After applying upper function, we are appending it a character not. So by this part, we will filter specific element from planet list. By this part, we are applying modification to the specific element of the planet list to generate a new list which will be stored in loud short planets. Click on the cell and run the cell. You can see Venus not, Earth not, Mars not. The transformation which was done on the fetched element after filtering was stored in loud short planet and printed on the user screen. People usually write this on a single line, but you might find structure clear when it's split over 3 lines. So this is the transformation planet.upper plus not. This is the iteration for planet in planets. And this is the condition. If length of planet is less than 6. So for every planet in planet list, if length of planet is less than 6, then the element is fetched. Then the transformation is applied planet.upper plus not. And we are storing this elements generated inside a list to generate a new list. Click on the cell and run the cell. Here new list was generated and directly printed on the user screen. We are not storing it into a variable and then printing it. We are directly generating it and printing it inside a cell. Now here we understand this code that for planets in planets means this line will iterate over each element of planet list. For the each element which is written, what we are doing, we are printing 32 directly. Means for each element returned, we are using 32. So new list which will be created will contain only 32 for every planet in planets list. Click on the cell and run the cell. For every element returned from planet list, we were using 32. So there are 9 elements, 0 to 9. So therefore for 0 to 9, 32 was replaced at every time. List comprehension combined with functions like min, max, sum can lead to impressive one-line solution for a problem that would otherwise require several lines of code. So, understanding this by example, we have to define count negatives on nums. Understanding the docstring, return the number of negative numbers in the given list. So we have to find the number of negative numbers in the given list. If a count negative function is applied to a list 5 minus 1 minus 203, it will return 2. So if we are not using list comprehension, we are just writing a normal function. We will use a variable to count the negative number. So we have used n negative is equal to 0 initialized to 0. For every element in num list, we are checking if that number is less than 0. If this condition is satisfied, then we are incrementing n negative count. Out of this for loop, we have checked for each element which is whether it is negative or not. We are returning the count variable and negative. Click on the cell and run the cell. This will create count negative function. And if we call this function, copy this part, enter, paste it here. We are calling count negative function for a list 5 minus 1 minus 203. Click on the cell and run the cell. You get a count 2 on the user screen, means this function is running correctly. Now we are writing the same function using list comprehension. So this part will be written for num In nums, then we will apply if condition. If num is less than 0, the element is written, then we will apply updation to the element. So that can be defined count negatives nums. Nums is the list. This part for num in nums, we are checking if num is less than 0, then that element is used for creation of a new list. After creation of the new list, we are finding out the length of the list. Means this returns all the negative numbers. Those negative numbers are used for creation of a new list, and we are finding out the length of the new list to get the count. So click on the cell and run the cell. You can see if you execute count negative function, after execution of this cell, you get count as 2. Now the same code was written 1, 2, 3, 4, 5 lines of code, and here only single line of code. It was producing the same output and doing the same thing. Well, if you care about minimizing the length of our code, the third solution is still better. What we are doing, we are iterating over num list. We are returning every number, and we are checking whether num is less than 0. It will return either true or false. Then we are applying some variable. So it will store trues for those elements of num list who are negative. So we will have 2 trues, and if we sum all the truth value, true is considered as 1. So 1 plus 1, the return value will be 2. A different version of the same function using sum instead of using length and having list comprehension. Click on the cell, run the cell. So again, count negative function was created. We will check whether it will run correctly or not. And below, call the count negative function. See, it was also giving the same output. This list has 2 negative numbers. List comprehension done in multiple ways for the same function. Which of the solution is best? Entirely subjective. Solving a problem with less code is always nice, but it's worth keeping in mind following lines of the Zen of Python. Readability counts. Explicit is better than implicit. That's it for today's tutorial, where we have studied loops and list comprehension. Do hit that subscribe button for more such technical content. See you in the next video.